Right, so we're going to do a couple problems kind of reviewing what we did yesterday and then move into some new stuff. So the directions for the standard problems right now are going to say show whether the series converges or diverges, and then if it converges, find its sum. And so I want to put two examples on the screen and let you guys try these. So let's do the sum k equals 1 to infinity of 5 times 2/3 to the k. And then let's also do the sum from k equals 3 to infinity of 4 times -5/4 to the k. So I'll give you just a minute or so to work on these two, but do what we were doing yesterday. See if you can review that and then check it with me in a minute and you can fix whatever, if anything's wrong here in just a minute. All right. Okay, so when we're doing these, both of these are examples of geometric series. So what we said yesterday is that a geometric series is one where it's in the form, or can be written in the form sum k equals 0 to infinity of ar to the k. And so we can go ahead and say, okay, this is geometric. And then what's important about the geometric series as far as determining whether or not the series converges. So you've got an A, you've got R, and then K is the variable here. Which one determines whether or not the series converges, A or R?
R has to be less than 1.
Yeah, the absolute value of R has to be less than 1. So we say, okay, this is geometric. The absolute value of R is 2/3. That is less than 1, so the series converges. All right, and so that is our quick proof, or us showing that the series converges. And then we want to know what it converges to, meaning find its sum. So if you add this series up, what does the sequence of partial sums approach? We said that the sum is a over 1 minus r. So I'm actually going to write it that way, a over 1 minus r, but it's a little bit misleading because the a in this formula does not necessarily match the a here. And whether we want to write it that way or not, that's kind of up to you. But this a does not necessarily match this a. It does if it starts at k equals 0. It does not if k starts somewhere else. What this a represents is the first term in the expansion of this series. So you plug in whatever this initial value of k is. So if I plug in k here, or k equals 1 here, I get 5 times 2/3, which is 10/3. So we're going to say, okay, well then it's 10/3 over 1 minus 2/3. And now we're going to simplify that. But is everybody clear where I'm getting 10/3? Good. Okay, so any questions? All right, so 1 minus 2/3 is 1/3. So we get 10/3 divided by 1/3, and then we flip the bottom and multiply. So we get 10 over 3 times 3 over 1. Here the 3's cancel. So we actually just get 10 over 1 or 10. And so this converges to 10. All right, any questions at all so far? Okay, and so then the next one, we're going to do the same basic approach. We're going to say, okay, well, it's geometric, but the absolute value of R is positive 5/4. that's greater than 1, which means that the series diverges. That means that we don't find the sum because there's not one. So if you calculate a over 1 minus r, that actually has no meaning here. The sum is not a over 1 minus r. There is no sum. When it diverges for a geometric series, that means it either goes to infinity or it goes to negative infinity, or it bounces between infinity and negative infinity for geometric series. Here, that's what it's doing. It's going to bounce infinity, negative infinity, but either way, it's going to diverge. Any questions on that? Okay. All right. So that's kind of, go ahead.
Would the only way for it to diverge to a negative number be if the a value is negative?
So for a geometric series, yeah. Oh, I'm sorry. No, that's not true. So James, I'm gonna have to think more about that question. So you're saying does this a value have to be negative for it to converge to a negative number?
Yeah.
Probably not. But I would have to think more about it. We'd have to think about what would make a over 1 minus r negative. And man, I think maybe you are right. I think maybe because r is between 1 and negative 1, that's going to be the case. But I'd need to think a little bit more about that to be sure. Does that make sense?
Yeah. Okay.
I think probably yes, but I'm not entirely sure. I have to think more about it. All right. Other questions so far? Good question. I just hadn't thought about it before. Okay. All right. So if you look at the homework, the ones you were supposed to do last night, the first 5 or 6 problems were all like this pretty much. There's some coming up where it looks like this, and I want to kind of review real fast this part. I think we've talked about it a little bit, and then it's on the review thing, one of the prerequisite videos. So if I have like, so let's say 16 minus 2 plus a half minus 1 over 8, and then plus 1 over 32, and then minus whatever's next, and then plus whatever's next. So directions are still the same. Show whether the series converges or diverges. And if it converges, find its sum. So this is a geometric series. How do we know that? What makes a series geometric? What happens when you go from one term to the next as far as what you're adding up? So what makes it geometric? Gonna let somebody figure it out. So yeah, you're multiplying by the same thing every time. And so to go from 16, man, this is not geometric, just kidding. This should have started at 8. My bad. Okay, so now it's geometric. So to go from 8 to negative 2, you can think of that as dividing by negative 4 or multiplying by negative 1/4. Man, it should have been confusing. The first one was not geometric. But if you now look at it, it's times negative 1/4, and then again times negative 1/4, times negative 1/4, and times negative 1/4. That makes it geometric. We can rewrite it in this form. We can say, okay, well, this is, let's do this in blue. So the black ink or the black writing is the original problem. What I'm writing in blue is our work. So I'm going to say, okay, this is the sum from k equals 0 to infinity of 8 times negative 1/4 to the k. And let's talk for a minute about why that works. The k equals 0 term would be the initial term in the sequence that we're adding up. The k equals 1 term is obviously the next term here. The idea is at k equals 0, you have not multiplied by negative 1/4 at all. When you get to k equals 1, you've multiplied 1 time. When you get to k equals 2, you've multiplied twice. When you get to k equals 4, you've multiplied 4 times. So the exponent here indicates the repeated multiplication. And you can plug in to make sure that this works, but it does. And so, like if I plug in 3, I get 8 times negative 1/4 to the third. Well, 8 times negative 1/4 to the third is 8 times negative 1 over 64, which is negative 1/8. So this is for k equals 3, just if we want to double check that formula works. If you need more review on how to come up with this formula here, that's what that prereq video is on. It's over how to find formulas for sequences. But once we get it to here, now this is the same as before. This is a geometric series. The absolute value of r is positive 1/4. That's less than 1, so the series converges. It converges to a over 1 minus r. In this case, a is 8, and you can double check that by plugging in 0. So if I plug in 0 for k, I get 8 times negative 1/4 to the 0. Well, that's 8 times 1, so it's just 8. So we get 8 over 1 minus negative 1/4. That's 8 over 5/4. That's 8 over 1 times 4 over 5, which is 32 over 5. And so this converges, and its sum is 32/5. Any questions on that? Everybody good?
I have one.
Sure. What's your question?
If I will find the SN1. I will-
SN,
SN1.
SN1? Like,
Yeah.
what do you mean?
Like I will do S0 plus S1, right?
If you wanted to find,
It will be 6, not
I think I understand what you're saying. So if you wanted to find S1,
yeah.
that would just be 8 minus 2, which is 6. That means the sum from k equals 0 to 1. Is that what you're asking me?
Yeah, thank you.
Or like if I wanted to find S3, that's the sum from k equals 0 to 3 of 8 times negative 1/4 to the k. Or if you wanted to find Sn, that's what we were doing yesterday with the system of equations. What we're doing here is finding the limit of Sn as n approaches infinity. I want to make sure I'm actually answering your question. Is that what you mean?
Yeah, thank you.
Okay, no problem. Other questions so far? Okay. All right. So yesterday's result was this. It said that the sum k equals 0 to infinity of ar to the k converges if the absolute value of r is less than 1, and it diverges if the absolute value of r is greater than or equal to 1. And the proof we gave yesterday was completely accurate for less than 1 and greater than 1, but kind of glossed over what happens if r is 1 or if r is negative 1. So if the absolute value of r equals 1, we haven't really explained why that's included on the diverge part of this. It is, so it is right to put it here, but we haven't really talked about that. So let's look at what happens on one where r is absolute value of r is 1. Well, if absolute value of r is 1, that means r is 1 or r is negative 1. And so we're not going to go through, and actually maybe I won't number it. We're not going to go through these as like standard examples. I just want to talk about what happens. So if r is 1, for instance, that would be an example where you have the sum k equals 0 to infinity of like 5 times 1 to the k. Does that make sense to everybody? So a would be whatever a is, and then r is 1. Well, that's the series 5 plus 5 plus 5 plus 5 forever. What do you think that does?
Diverges.
That diverges, because if I add an infinite number of 5s, then I should get infinity. Does that make sense to everybody? Okay, so that's true if a is 5. What if a is really small? So what if a is like 0 to infinity? What if a is like 0.001 times 1 to the k, then that's 0.001 plus 0.001 plus 0.001 plus forever. Does that still diverge, or is that small enough to where it's going to approach a finite number?
It's still diverging. It's still adding.
Yeah, it's still diverging, and it's because every 1,000 of those, you get one, and that seems like a lot, but if you're talking about 1,000, that's not very many when we're talking about n going to infinity. Remember, we're going to have billions and billions and billions of these. So when every 1,000 you get one, well, then you're going to go to infinity eventually. So if no matter what a is, this is going to diverge with maybe one exception. If this was negative, then this would be negative and then negative and negative. It would go to negative infinity, but it would still diverge. What would be the exception? What value of a would make that not diverge? What do you guys think?
0.
0. So if a was 0, then okay, it doesn't diverge. But if a is 0, then okay, that's the sum k equals 0 to infinity of 0, which is 0. And so that's kind of an exception to everything we're talking about. That converges no matter what, but there's not really an r anyway. It's just artificially there. So aside from a equals 0, when r is 1, this diverges. Does that make sense to everybody? You guys clear? And we could probably just say, okay, we're going to assume a is not 0 because that's a special case. So, okay, if r is -1, then here would be an example. So I'm going to do it where k equals 0 to infinity of 1 times -1 to the k. So a is 1 this time. So then, okay, if I plug in k equals 0, I get 1. If I plug in k equals 1, I get -1. If I plug in k equals 2, I get 1, and then -1, and then 1, and then -1, and then so on. Now we've set up here it diverges, but why is that? So why does that diverge? It clearly doesn't go to infinity. It clearly does not go to negative infinity. It actually looks like it goes to 0.
Because it bounces back and forth.
Yeah, it bounces back and forth, but maybe not between what we would think it bounces back and forth between. So remember, we're talking about the sequence of partial sums. So here, S0, that's the sum from 0 to 0, which would be just 1. S1 is the sum from 0 to 1. So that'd be 1 minus 1, which is 0. S2 is the sum from 0 to 2, which would get you, remember, this is A0, A1, A2. So you would add up to that second one, that's 1. S3 is 0. S4 is 1, and so on. If I figured out like something big like S1 million, then okay, based on that pattern, that's going to be 1. It's all the evens are 1, all the odds are -1. S1 million and 1 is -1. And so that diverges.
Wait,
not
0.
because, my bad, this is 0, thank you. That diverges not because it's going to infinity or negative infinity, but it's bouncing 1, 0, 1, 0, even though it kind of looks like that should be 0. It is 0 every other term, but it's 1 every other term as well. Does that make sense to everybody? Yes, clear. Somebody asked that yesterday, and we were going to talk about this today anyway, but it's definitely worth looking at why it diverges when absolute value of r is 1. That would be where r is 1 or r is -1. Everybody clear?
And so the only reason you can't say it converges to either one is because you can't say if infinity is even or odd.
Right. Like the technical definition of converging means that as n goes to infinity, like once n is big enough, all of the terms are infinitely close or as close as you want to the limit. So if you said the limit is 0, you have to be able to say, okay, from the billionth term on, they're all within like 0.1 of 0. Well, that never happens because you always get another one that's not near 0. You get 1 every other term. Does that make sense?
Mhm.
Okay, and that's getting a little more into the formal definition, but when you're bouncing between two separate values, two values that like if you're right above 0, right below 0, that's different. But if you're bouncing between two different values like 1 and 0, or even like 0.1 and 0, then that diverges because those are two discrete values, two separate values. All right, when that happens, it does diverge. All right, any other questions to hear? Everybody good? Okay, I want to talk real quick about, I want to talk for a minute about series if you add them up. So like if I have the sum of AK and the sum of BK, so these infinite sums, I want to know about what happens when you combine them. So if you have two series and like, maybe these both converge, then okay, what happens here? And then same backwards. So can you split this? So like, if I add these two, do I get the same thing as here? So let's think about what happens if these both converge. So AK and BK are two separate series. They both converge, maybe not to the same thing. But if they both converge, then that means, okay, when I add all the A's, then I get some finite number. I approach some finite number. So I don't know, maybe that converges to 6. And then this converges to something else. Maybe this converges to 4. So, okay, we'll say this converges to 6 and this converges to 4. So you add all the A's and you get 6. You add all the B's and you get 4. What do you think would happen if you added like each independent value of A to each independent value of B and then totaled it? You guys get what I'm asking? So like this is A0 plus A1 plus A2 plus forever. This is B0 plus B1 plus B2 plus forever. This is A0 plus B0, and that's a B, plus B0 plus A1 plus B1 plus A2 plus B2 plus forever. So you're adding them first and then you're adding like A0 and B0 first and then doing it. What do you think happens? If this goes to 6 and this, say it again, sorry.
It goes to 10.
Yeah, it goes to 10. So if these both converge, this converges to the total, so you can split it up. So, okay. That's good. What if instead this one converges, but this one diverges? Let's think about how that can happen. So if this converges, we'll say it converges to 6 again, okay? What do you think the easiest way, if you add up an infinite number of numbers, the most logical thing would be that that would diverge. Why? What if you add up an infinity numbers? What if you think about it without going into a lot of detail? What should you get? If you add up an infinite number of numbers, what should that probably be? Why would it normally diverge?
Go to infinity?
Yeah, it would go to infinity. Yeah. So, okay, one way for a series to diverge is if it goes to infinity. What's another way for a series to diverge?
To not settle on a single number.
Yeah, like it could bounce like between two values, like 1 negative or 1 0 1 0, like we were just seeing, or maybe it bounces 4 7 4 7 or something like that. Another way is negative infinity, right? Okay, so if this one, if what we know is that this one converges, that means it goes to a finite number like 6. And then we know that this one diverges, that means either it goes to infinity or it goes to negative infinity, or maybe like does something weird, like bouncing between two things. Maybe there's some other cases, but these are like the main things that happen when a series diverges. It either goes to infinity or it goes to negative infinity, or it bounces between stuff. All right, and so if this one goes to infinity and this one goes to 6, what do you think the one over here does? This AK plus BK, what do you think it would do?
Go to infinity.
It would go to infinity, yeah. So, okay, if it's 6 plus infinity, that's infinity. What happens if this one goes to 6 and this one goes to negative infinity? What would the one over here do?
Negative infinity.
Yeah, negative infinity. Now, what happens if this one mounts as 4747 and this one's 6, then what's this one going to do?
10, 13.
Yeah, 10, 13, 10, 13. No matter what does the one over here do? Does it converge or diverge?
Divergent.
Diverge.
It diverges. So if you add two series and one of them converges and the other one diverges, then the total diverges as well. Does that make sense to everybody? We clear? Okay. So we're going to copy that green conclusion up here. So if this one converges and this one diverges, then this one diverges. Now, what if they both diverge? Okay, so down here, let's talk about what happens if they both diverge. So the easiest way for them to diverge is if they both go to infinity, right? So if they both go to infinity and you add them up, what do you think the total does?
Goes to infinity.
That goes to infinity. What if they both go to negative infinity? What happens to the total?
Negative infinity.
Negative infinity. Now, what if one of them goes to infinity and one of them goes to negative infinity?
You won't be able to tell unless like one's a lot going to infinity a lot quicker than the other.
Yeah, that's hard to tell. So you can't tell unless you know which one's going faster. That's the whole thought process behind L'Hopital's rule that you learn in Calc 1, that going to, so like infinity minus infinity does not have to be 0. It can be, but it could also be infinity. It could also be negative infinity. It could also be like 12. Like it just depends on how fast this is happening. And so we don't know. That's what's called an indeterminate form. So this could converge or maybe it would diverge. We absolutely don't know. What if it does this? So what if this one diverges because it bounces 3, 7, 3, 7, and this one then bounces 2, no, let's do 5, 6, 5, 6. So then, okay, what does the one over here do if they bounce like that? 8, 13, 8, 13, which would mean it would diverge as well. Does that make sense? Okay, but what if instead this diverges over here by going 5, 1, 5, 1? So this series diverges, but it goes 5, 1, 5, 1. Then what does the total do?
8, 8, 8, 8.
Yeah, and if it's 8 every time, what does it do?
Converge.
Converges. So there are ways to have, if you have AK and BK both diverging, there are ways where this could diverge, but there are also ways where this would converge. And so it's not clear, only knowing this, what happens over here. So the idea is, remember when we did integrals, we wanted to like split them up? What we want to do is we want to be able to take a series like this. So we go back to like our standard examples. We're on example 4. So we want to be able to take a series like this and split it. So if you remember doing integrals, it might make sense that we would want to do this. And so the question is, can you do that? Does everybody get what I'm doing here? Like if we're allowed, that's like what we would do with integrals. Does everybody see what I'm talking about? Okay, so the question is, can you do that? And that's what we're getting at up here. So when can you split it? So like, when is it clear that this is going to do the same thing as these do? If they all converge, so like, and even if I had more than 2 of them added up, if you have a bunch of series added up and they all converge, then the total converges. Does that make sense to everybody? We clear? Okay, if you have a bunch of series added up and exactly one diverges, then what does the total do? If exactly one diverges, but all the rest converge, then the total diverges. Does that make sense to everybody? Okay, as soon as two or more diverge, then it's not clear. So we cannot split it up without knowing more about why they diverge. Does that make sense? We clear? Okay, so what do you think? Without going any further, or maybe going one more step. So if I do this, I would want to then say, okay, that's the sum k equals 2 to infinity of 3/5 to the k minus the sum k equals 2 to infinity of 4 times 1/5 to the k. Okay, so from here to here is for sure allowed. Am I allowed to do this? So I am allowed to do it if they all converge. I am also allowed to do it if exactly one diverges. But if two of them diverge, then we may or may not be allowed to do it. It depends on why they diverge. What about here? So can I split it or not, and why? Any ideas? So what do these do? What does this one do? Does this converge or diverge?
Diverges.
That
Converges.
I mean,
converges.
converges.
Yeah, it converges. And then what does this one do?
Converges.
Also converges.
Converges. So if these both converge, is that the same as the total?
Yeah.
Yeah. So this is allowed because we know both of these converge. If they both diverged, then we might not be allowed to do it. If one converged and one diverged, then that's okay because then the whole thing diverges. Does that make sense to everybody? That's the rationale for going through what we're going through up here. We are allowed to split addition and subtraction unless two of them or more of them diverge. If two or more diverge, then we need more information before we're able to split it. Or we may not be able to split it at all. Does that make sense? Questions? Okay, so now, if the directions on this said, okay, show whether this converges or diverges, and then if it converges, find its sum, then okay, we would do this. And I didn't write it in blue, but I should have. So I'll put a check mark here saying, okay, if this is the original problem, I would first split it like this and then rewrite it like this. Does that make sense? And now I would show what each of these does. So I would say, okay, well, the sum k equals 2 to infinity of 3/5 to the k converges because it's geometric. The absolute value of r is 3/5, which is less than 1. And then I would also say, okay, the sum k equals 2 to infinity of 4 times 1/5 to the k converges because it's geometric. Absolute value of r is 1/5, which is less than 1. So the original series converges. Because it's the sum, or difference you could say, but I'm going to say sum of two convergent series. So what I've got written on here, everything except the original problem, the stuff over here and this stuff down here in blue, that is our proof that the series converges. Does that make sense to everybody? please ask if any of this doesn't make sense, including this algebra, like why is this 4 not in the parentheses? Make sure all of that makes sense because there's a lot of subtle stuff going on here. Please ask if anything does not. Everybody
Why
good?
did you rewrite the 4
Okay,
in front of the 1/5?
because on the 3 is to the k, but the 4 is not. And so this is the same as 3/5 to the k because they're both to the k. 1 to the k is the same as 1. So what I'm doing here is I'm treating it as 4 times 1/5 to the k, which is the same as 4 times 1 to the k over 5 to the k. And then I'm getting to there. Does that make sense?
Yeah.
It's mainly because that 4 is not to the k power. All right, other questions?
Would you have to split it up like this in order to figure out if both parts like either converge or diverge? Like, do you have to set it up like this every time in order to figure out how you move forward?
So there are some tests later where we may not need to split this one up. But if we want to find the sum of the series, which that's what the directions we were given said, then we would need to split this one up because it's 2 separate geometric series. Does that make sense?
Yeah.
Okay. So later, so remember there are 2 parts of this problem. We're not done with it. The first part is to show whether it converges or diverges. The second part is if it does converge, find the sum. Some series, we won't be able to find the sum exactly, and we'll just want to know whether or not there is a sum. So whether or not it converges. If that's all we're looking for, sometimes there's a way around splitting it up. There are other tests that could show you that this will converge without actually finding the sum. We haven't learned that yet. So right now, this is all we've got for this one. If you want to then find the sum, which we do right now, but we can't always, then this is the best way to do that on this problem, no matter what we learn later. Does that make sense? Does that make sense to everybody?
Yeah.
Okay. Everybody good? Okay, so now to find the sum, we're going to come back up here and say, okay, S is, remember it's A over 1 minus R, but it's A over 1 minus R for each of these. So it's 9 over 25 over 1 minus 3/5. I'm getting 9 over 25 by plugging this 2 in here. And then it's minus 4 over 25 over 1 minus 1/5. And I'm getting that by plugging the 2 into the second series there. And then there's just a bunch of fractions to simplify. So we get 9 over 25 over 2/5 minus 4 over 25 over 4/5. We then flip and multiply. So 9 over 25 times 5 over 2 minus 4 over 25 times 5 over 4. These cancel and simplify, and so you get 9 over 10 minus 1 over 5. That's 9/10 minus 2/10, so we get 7/10, unless I made a small mistake with fractions, but I don't think I did. I think that's good. All right, questions? So it converges and the sum is 7 over 10. Okay, I want to look at one more and then move into a different type of series. So okay, so we've done some of this algebra when we were talking about sequences last week. So we're going to kind of go quickly through it. And then there are a bunch of examples where you can practice the algebra on the series 1 packet. You remember you have solutions to those, but there's a bunch of those where you can go through and actually see how I've dealt with the algebra and stuff like this. But it should make sense from what we were doing last week that we can rewrite this as 5 to the negative 1 over 6 to the 3rd times 25 over 6 to the k. And then if we want to rewrite that, we can write it as 1 over 5 times 6 to the third, which we could figure out, but I don't really want to. And we get it to there. Questions on the algebra there? Everybody good doing that? Okay, so now this is geometric. The absolute value of R is 25 over 6, which is bigger than 1. So the series diverges. And then we don't find a sum because there's not one. Any questions so far? Okay, so I actually want to talk about this worksheet for a minute before we move on. So if you go into Google Drive on our shared drive in the Unit 3 folder, folder 2, so Unit 3 and then folder 2, it's series. There's the geometric series, series 1 handout. We should complete this before the next lecture. So before tomorrow's lecture, or if you're watching this later on a recording, before you watch the next recording, you should finish this whole handout. So the first 5 problems is what we should have done before today. And then if you look through, okay, the next ones are ones where you need to write a formula first, and then from there determine whether it converges or diverges. And if it does converge, find the sum. Then there's some more examples like what we're doing where you have to do various algebra in order to get it so that it looks like a geometric series. So we've kind of gone through an example like that, but I do have worked out solutions if you need more practice with the algebra and manipulating the exponentials. Then there are ones where you need to split them up and determine whether you can split them up in order to figure out what the problem is doing. When you see me doing problems like this, where they're very, very similar, in fact, at first glance, they look the same, I'm trying to get you to notice something about those problems. And so you should look at what is the difference between this problem and this problem. And then down here, what's the difference between this one and the one up here? A couple with decimals, and then a weird one with cosine, which looks hard, but if you think about it, is not insanely hard. This is actually a good spot to stop before tomorrow's lecture. So we are going to quit a little bit early today. We're going to start tomorrow. So the series that we've talked about so far, obviously geometric series. The reason we cover geometric series first, one is because there's a ton of applications of them, but another is because these are ones where we are able to get a formula for the partial sum. So yesterday, what we were doing is we used a system of equations, that real long thing we were doing, in order to find a formula for the partial sum. That's what we're now using to show what the sums of these are. Tomorrow, we're going to start with a type of series where you can also find a formula for the partial sum. But most of the time, that's not something that can be done. So we're going to look at one more type where you can find a formula for the partial sum, talk a little bit about that, and then talk about when can series in general, if whether they're geometric or not, when can they converge and when can they not? And that'll move us into Thursday and then next week. All right, if you have any questions, feel free to stick around. We've got a few extra minutes, but that's it for the lecture part of today. So if you have questions, stick around. If not, I hope I'll see you guys tomorrow. Thanks for coming, you guys.